Okay, so I'm ready to test my homemade lithium battery pack. I've got it's wired up 5 in parallel, 3 in series, so it's like nominally around 12 volts. And it's going to power my homemade robot Raspberry Pi thing, which is in progress. But this is ready for testing. So I did the usual setup with this is my ammeter in series with this whole thing, and this is my voltmeter up here. So you can see it's fully charged, maybe a little bit overcharged, and I've got a 3.3 ohm resistor in there. It's the lowest one I could find that I have. I've got a bunch of power resistors. I have like lower ones that are like 0 or less, but they're small, and I don't want to break them, so I picked a power resistor, and that's the smallest one I have. So let's get started. So should be everything ready. I just need to clip this onto the battery terminal. Okay, here we go. Sparks maybe? Oh, no. So you can see 3.6 amps drawing. Starting to bubble. You can see the voltage dropping. Not too fast though. These are supposed to be high discharge cells. They're half LG cells and half Samsung cells. They're the 3000 milliamp hour cells. So they're really good, expensive cells. I'm expecting them to perform well. Yeah, so maybe I'll start recording again when it starts boiling. Okay, so we are 42 minutes in almost, and it's sort of boiling. There's lots of bubbles, but I think it's just dissipating the heat too well. And the heat output is not that much. It's like 30 watts or so at like 3 ohms, and yeah, it ends up being just 3.5 amps and around 12 volts, so like 36 or so watts, which is not enough to really get it boiling properly, but it is bubbling, and the water has turned some kind of gross, scummy, like pale white from, I guess, the resistor dissolving somewhat. So yeah, just an update. I kind of messed up the DMM, and I am not going to be able to get a full data series out of this, but I still got most of it. It's recording now. So should be able to get a nice graph showing up in MATLAB of the drop and integrate it and see what the total amp hourages of the battery is. I'm switching up the experiment. Part of the reason of doing this was to make sure that the battery pack could handle the load and handle the heat, because I kind of wrapped it all up in tape, and I'm kind of concerned about that, especially these MOSFETs on the top. So I need to give it more load. So I have this really sketchy setup where I just added a 1 ohm and a 0 ohm resistor in series here across the 3 ohm other resistor in parallel. These are garbage resistors too, so they're like way off spec, and I think this is like 0.8 ohms or something. So it should be fun. Put it back in the water, which is, by the way, boiling, or almost boiling. Definitely too hot to touch. And we got all the same setup here. Almost 12 volts. Batteries are still doing well. Let's clip it on. And we can see it boiling. On the right wires too, so at least the contacts are working. I did check it with the ohm meter, and the connections are good, although very sketchy. So let's see what happens here. I also really messed up the multimeter again and lost all the data I've recorded so far, so at least it'll make the analysis easier because I don't have to break it in the middle. Maybe I just noticed that it's only drawing 3.4 amps, so yeah, the bypass thing is not working. The connections are terrible, so I'll pull it out and solder it properly. I've got it wired up to just a single 1 ohm resistor, and I'm actually going to recharge the batteries. It's drawing like 1.5 amps. I'll probably come back to this tonight after work and try this again with clean water. Okay. It is later today, I've got a 1 ohm resistor in there still, and let's put it in first so that it doesn't explode instantly. Nice clean water. Okay. Setup is all the same. I'm going to not fuck up the multimeter this time, so we should get a clean graph in MATLAB and charge it to exactly 12 volts this time, instead of using this charger thing that I don't know what it charges to. It was more than 12 volts, but 12 is fine. That's the nominal voltage of my robot project anyway. So let's hook this up and get going. See, it's not drawing anything. Hang on. I'll check continuity and stuff. Well, it was drawing a little bit, so I guess it's the controller on the battery that doesn't like the amount of current draw I was taking or something. I'll figure it out. This piece of trash 10% tolerance film resistor was reading like 300 kilo ohms, so it's supposed to be 1 ohm. I got it pretty far off. All right, let's hook it up. Is everything? I need to hook up the voltmeter. There we go. Still 4 milliamps. Did I put the wrong resistor in? Okay, so it turns out that these metal oxide film resistors just die when you put them in water. Because I tested this before I put it in, and it was, off a lot, but it was around 1 ohm, and now it's too high for the meter. I need like an insulation tester or something. So I need to find a new plan. Maybe I'll try a different brand of resistor, or just resort to wire. Theory that maybe I just burned out the resistors when I put current across them. So I'm going to try, well, first of all, I'm going to try dunking this and watching it on the ohmmeter to see whether it dies when I put it in. Okay, it's in. The resistance fell a little bit, that's funny, from the parallel resistance of the water, I guess. Our beautiful San Francisco water. It seems to be doing fine. Maybe I did just burn it out. 12 volts. I mean, that is a hell of a lot of current for that little film oxide or metal oxide film resistor. But it's in water. I thought that would be fine. Well, I'll try with the 1.5, and hopefully this one is a little bit beefier. I do have another brand of resistor that's not from a terrible kit with the 10% silver tolerance band on it. But I don't know if that'll be any better. Okay, let's see. This in. I was testing the resistance of this little extruded aluminum truss thing here, and I thought it was like really high. Wow, I didn't realize aluminum was that resistive. And I put it in the water and thought I'd check one last time on the desktop, or the desktop multimeter, what the resistance is. And once it's in the water, it actually makes good contact with the wire with the aluminum. And turns out it's like really low. Like the total resistance through the ammeter and everything is like less than 100 milliohms. So that would have just been a disaster. So I have to find a new solution here. So I think I got it here. I'm pretty sketched out by this setup, but I don't know, it could work. Basically I've got, 10 or so meters of nice solid core copper wire with silicone insulation. So I guess I might be giving up for this if this fails catastrophically somehow. So end to end it measures about 800 milliohms, and with 12 volts on the meter, that's 15 amps, which is under the 25 amp rating of this thing, this board. 15 amps at 12 volts would be 15 times 12 is 165 plus 15, 180 watts. So this little glue stick is going to be putting out 180 watts, but I guess my main concern is that the heat will be generated, throughout all the wires and stuff, and not just in the water. Because it's all copper. I couldn't find any insulated steel wire or anything that's less conductive than copper. I have uninsulated steel wire, but that's not very useful. Okay, let's give this a shot. If this explodes, you'll see it. And it'll probably be titled in the video, so you already know. But, okay, here we go. Sparky sparks. Okay. It's a little bit scary, but apparently it's going. It's not getting deadly hot immediately. Voltage is dropping a lot faster than it was before. But I guess it's going. I had to take the Fluke out of the series because it's fused for 10 amps, and we're running 15 amps here, so that would have blown the fuse. I don't know. Let's see what happens. Alright, the voltage is dropping pretty fast. Let's see, this wire is not warm at all. The batteries are actually not even detectably warm at all. The passives up here are a little bit warm. The MOSFETs are hot. Yeah, they're hot, but they're not like scalding hot. Whoa, the glue stick is falling apart. Look at that. It buckled under the weight of the wires. You can feel it being really floppy. And it's starting to bubble a little bit, but it's not boiling, not even close. The water's warm. Actually, it's hot, but it's not boiling. Seems to be holding up. I'm a little bit concerned about the MOSFETs, but the wiring seems fine. And the water seems to be taking up the heat, so I'm happy about that. The glue stick has given up the fight. Ugh. I'm not getting that wire back. I just remembered that I have an infrared camera. So let's take a look. I'm interested to see this circuit board. Yeah, it's kind of all hot. What is that? Degrees freedom. 125. That's not bad at all. It's probably being reflected by the tape. See if it's too hot. What is that component that is super hot? Looks like a resistor. Five ohm resistor? Yeah, that's hot. Ooh, the water's even hotter. 133, 140, 150? Not close to boiling, though. Interesting. Where are we down to? Okay. Supposedly the battery management board there will cut it off before it gets undervolted. If I see that dip much below 10, or maybe 9.8, I'm going to be really concerned. I don't know. I think like 9 is the point where they are really actually damaged. So I don't know where it will cut off. I read an Amazon review saying that it did a poor job at undervoltage protection, so I'm watching it closely. We have steam. Definitely boiling away. You can smell it. It smells like glue. I just noticed that the hot glue is forming like a stalagmite there, where the the bubbles rise. It's chugging away now. I have another toy here that I found in the junk drawer. I mean, it's clearly boiling. I think the IR sensors must be the IR sensor must be thrown off by it reflecting partially off the glass, and also the emissivity maybe of the wire underneath, because I don't ever know what to set that to. Let's take a look at this resistor here. Yeah, it's just not precise enough at this distance. 100 Fahrenheit. It says the MOSFETs are hotter, so yeah, I guess it's just not picking up on the little resistor there. Problem is, if you get too close, the laser gets out of alignment with the sensor. It's hard to tell. Oof. Yeah, that's hot. I think I'm going to move my LED overlay out of the way. The smell is really bad. It's really bad. I thought the fumes from burning JB Weld that I used to assemble the battery pack were bad when I was soldering it. This is pretty unbreathable. And it's sort of raining outside, so I can't really get my window open too much. I might have to cut this short. We are down to 10.5 or so volts. Still chooching. I might be able to do some kind of interpolation, figure out sort of the pattern where it might be about to fall off a cliff based on a slope or something. Because I don't know, this smells really bad. It is burning glue. That's what it is. Ugh. There's the foul goop bubbling away. It's bad. It's real bad. It's actually like sputtering now and spurting like a volcano. Got the AC running. I'm imagine my fire alarm's gonna go off soon. It goes off all the time when it's I'm cooking, so it's really sensitive. Still holding at 10420, funding secured. Alright, yeah, this is it. It stinks too much. I've been, I think I'm going to build a new battery pack also as a second one to power this. I'm going to get a proper shrink wrap instead of using this tape. And, whoa! I'm going to... Oh my god. I'm going to get, fuses also on the leads instead of just nickel bus bars. Alright, that's it. Yep. Experiment over. I can't breathe. Alright, so this is kind of interesting. You can see the battery start to drop. Kind of slopes off there. Looks like it was going to go for a while. If it was... I don't know. I guess there's an inflection point where it starts dropping more steeply, but you can see this is where I disconnected the this is where I initially disconnected the battery? No, what is this? Because this is where I disconnected the battery. You can see the voltage spike way back up as the battery chemistry recovers. Well, I guess this after here is the chemistry recovering. This initial spike is just from there being no load carrying or pulling down the voltage. But this drop is interesting to me. I don't know what this was. I have to think about that. Anyway, this is the data. Unfortunately, I don't have timestamps, so it's kind of hard to analyze the total amp hours. I forgot to start a timer for this test. I don't know. This is interesting to me. I'll have to think about what this means. Okay, so I'm dumb. I realized that you can just take it as a constant sample rate. It turns out my DMM takes 2 samples per second, so I could get time out of that. And it turns out that this little drop down was quite a while before the end. This was about 400 seconds before the end. So my guess is that this was actually a short. Like the silicone insulation melted at this point and dropped the resistance significantly down, which would bring the voltage down as well. And then when you disconnect it, it goes shooting right back up. So, mystery solved.